Hello everyone, welcome back. Here I'm writing a programming language in Rust. What is the language? So currently I'm working on Seed, which is going to be a C-style language core made up of base components that most programmers will be familiar with from lots of mainstream languages at the moment, like JavaScript, C, C++, Rust, Go, and the likes. And I'm using that as a basis for playing around with future language ideas that I have, primarily to build a language I'm provisionally calling Ash. It's going to be a Bash alternative, and with a focus on keeping the ergonomics of Bash while presenting maybe a more familiar C-style syntax to the developer. Where am I with it? I'm about 70%, I would say, done of the programming language core. So I'm working on some of the, more. So I think the majority of the core features more or less done at this point. Now we're getting to features that are a little more specific, so things like range indexes and range operators and things like that. So we're a good bit of the way done with the core, but the progress has kind of slowed down a bit. Before I was getting about 3 features done in each stream, because I'm mostly copying code over from a previous project and adding tests and the like and doing little refactorings. Things have kind of slowed down now. The last feature, which was range indexes, took a little bit of time to get done. And so just to finish off, the tools that I'm using to develop this are, I use Mosh to connect to my development server. So even when the connection gets flaky or drops, the Mosh connection will continue regardless. I'm using tmux to split up the session into different projects and panes. I use Vim for my development, more or less vanilla Vim with custom Vim RC, but very few plugins. I use one nerd tree plugin, and I use ENTR for rerunning the project whenever files in the project change. I also use a project that I've written before called Doc, which just helps me run commands in the development environment defined for this project. Now, before I dive into today's coding or the actual feature, we got a good, piece of the implementation puzzle done yesterday. But before I'm going to dive in, I did a bit of space reclaiming before I started the stream, and that's something that I noticed about the project yesterday, was that I've noticed as I've been working on it the last couple of days, my disk space has actually been filling up quite quickly. The project is still called Skelelang for skeleton language in the project name, but it gets uploaded to Seed on GitHub. So I want to write a little watch script that can help me keep an eye on things like disk space. So what I'm going to do is have 2 little windows here. This is where I'll actually run the script that I'm developing. And I'm going to write the script here. Eventually I'd like to be able to write this in my own language instead of writing a bash script. So that could be a nice bonus if all goes well. So let's see. So I'll do a watch with interval 0.1 of a second, I guess, at the moment, and bash monitor Yeah, so there's nothing going on at the moment. And so first, what will I do? Will I do just a general df of the current directory, I guess. And will I guess I'll split that up. I think okay. So we'll get the second line, and I'll do cut with a field. So I think I have to provide a delimiter, but the field that results from it, I think, can be, because it splits on every space. What's my best way of removing, of just getting this available section? If I just jump, so 15, 14, okay. It was a bit hacky, but we got there. So I will, what was my query? Tail -1. And cut with a delimiter of space, and it was field 14, wasn't it? Delimiter must be a single character. Okay. And I can probably remove that. Oops, that changes. Okay, yeah, I'll make it human readable again. So that's monitoring the disk space of the whole partition. Do I have NCDU installed? Okay, yeah, that's a smoking gun there. The target directory is 6 gigabytes, and debug. Is it keeping? What is that? Is that? Well, depths is pretty big as well, and that seems to be Lallerpop primarily. I might not actually need my special monitor script. I might be able to just, oops. And the incremental build, that's fine, but so each of those builds and it's the build script build is nearly 100 megabytes, and those are stacking up quickly. So let me see, I don't need most of them anyway. Let me see, can I do a, if I run doc and I, doc isn't in my general path. I think this is probably a very old instance of this shell. So I think, I can't remember where in fact. Okay, so doc isn't available, but I can run it. Oh wait, that's because I'm in the... So I will update my... I think, do I put it into my profile usually? Yeah, and I'll... start a new... Oh, because... Let me throw that over there and... And so I'll actually do it to the release, set it to the release directory. No, that didn't work either. Am I missing part of it? I might actually have to increase the screen size a little for a moment. Okay, so it actually is just up until doc D. So profile. Oh, I forgot that. Okay, yeah, so that's all right then. So I now have doc in the rest of my environments again. So with that said, I'll go into doc here and I'll do a cargo clean and see, yeah, instantly I'd say 10% of the disk space seems to have gotten reclaimed. Yeah, that was about 6 gigabytes. And let's do NCDU again. Oh, well, it's just removed the target directory completely. I mean, that's fine too. But let's see what happens when I kick off a build again. It's going to take a while now because it's starting from scratch. Yeah, it's gonna have to fetch all of those. Yeah, that's gonna be working away for a while. So while that's working away, I might as well. So at least that's the disk space puzzle somewhat figured out. And so I'll go ahead and start implementing this range operator. So I believe I've updated the Lexer with everything I need. So I need to update the AST. That's all that's needed there, I would say. And this will probably be a relatively straightforward feature, I would say. yeah, like there isn't much to it. Where am I in the AST? I now have it below range index. Yeah, I think that will more or less be it. And I'll need to add those error types. So they'll be going above eval prop name. And I'll need to add support for those in main. I have dot, don't I? Yeah. So that's the errors handled and unwrapped. And let's see where the compile is. It's a bit of ways still. So I'll go ahead and start adding some. Will I put this in operations? What other features are gonna go in? And will there be a different file I can put them in? So spread and unspread will do with assignment. I have print returns. Do I have any? So I have lexical scopes, but I have no file for dedicated assignments. I suppose those will go under assignment. That'll go under strings, or go in with the rest of the strings. Tests. Error handling. I probably won't add a proper error handling mechanism in this language because that's something that different languages often handle in their own way. So if I'm using this language as a base, then that's something that I'll probably want to be customized in different languages that are based off of it. Hi, welcome. It goes well. So, and then the rest of the assignments as well, which will include spread and unspread when I get to that point. So I guess I'll put range in with operations, even though that seems a little dirty, but I guess so. It's probably mostly complicated just because of the way, well, complicated in one way. I guess it's developing a programming language, so by nature there are a lot of layers to it, but at the same time with my file naming schemes and things like that, it tends to complicate matters even more. But in general, most of the development boils down to updates to the parser and the AST, which really just is what the parser will generate in an iteration. The evaluator, which is where the AST will get evaluated, and then the test files. And the test files are developed in such a way that I have multiple tests per test file, but there's no syntax highlighting in these, so it looks a little, it can look even a bit more complicated, but really these are all just different test sections or test cases, I guess, where this is an example source file and this is the expected output. So in reality, there's only a few core areas where there's going to be stuff that matters, but I can be a bit messy in my workspace, so that can sometimes make things look a little more complicated as well. So we have variables, and here I will add range. So I'll do a simple range here. So this should be 1, 2, and so this is going to be inclusive of the start element but exclusive of the end element. So basically I'll call it Python style, but different. Different languages also have this. And I think the build has actually called up now. So this will actually run when I make changes. I think that will actually be empty. So if the end is less than the start, then I don't think it's going to contain anything. So that's an issue with the parser. Oh, interesting. So I've already okay, there's still 8 gigs left, but yeah, I guess that's still 90% of the disk space taken up. But anyway, going back to the parser, it's saying expected a tuple. Okay, yeah, so I need to add the locations. That's a bit annoying. If I could replace either of those with an expression, then that would simplify things a bit. But I can't, so because of what I discovered yesterday. Oh, just pushed over the character limit. I don't really like these simplified, and actually I need space for the parentheses as well, so that can't be helped. So I haven't updated the cargo version, and I'll need to update the features file. Oh yeah, I need to update bind because that's a new production. Will I put this feature close to... No. Put it here. So that's features. So I have some errors. Yeah, that makes sense. I can correct that shortly. operations tests. Oh, I need to make sure that the check line length script is there. So if I go to my, oh, I don't have a make file at the moment. So that's all right again. So I'll kick off the dev loop again. Now I'll have to correct that at some stage because the project, well, it'll build and run without the style checker, but the just file script is broken in that way. So now we don't have a way of doing a reverse range. And so maybe that's something that I should allow, because this will be the principal way of doing integer loops so for I equal to 0 and less than or greater than whatever number. So it'd be good to have that, but for the moment I'll just say that these are the rules, and that, again, that can be something that gets customized in the language that gets built on top of this one. So let's see. Welcome back. So from an inclusive start integer, or I guess integers is implied, to an exclusive end. If the start is greater than or equal to the end, then the resulting list will be empty. And I'd better make sure that that's the case in the features test as well. And what was the error I was getting above here? So it was a Clippy suggestion, and that was for mod in the evaluator. 596. Oh yeah. And how are we on features there? So we have the documentation updated. We have the errors handled. The Lexer updated. That was a style change that I added there that I can move later. So the precedence operators got bumped. Did any file change that wasn't changed before? Do I need to bump the copyright anywhere? Not sure. Oh, I possibly have to bump it in the... No. Anywhere else? No, I think that's... And this didn't change yet, so... Okay, so that's the range operator done. And so we're getting onto the likes of object shorthand. So how does this one work again? So I obviously made a specific backup file for handling that. So let's dive into there. Yes, so I had a special AST type for this. So prop items. So before I jump into that, well, I'll add it to the scratch file to do. In fact, maybe I should do that now, because otherwise the project is in a bit of a broken state in a way. So we'll go to the README and we're gonna say building So to build the project, it's gonna need to call to install the dependencies. That's a phony target. No, it's an actual target. But maybe I'll create a phony target for installing dependencies. So I don't need those rules anymore because I've moved most of the phony. Actually, maybe that's a good call that I should put this into the just file as well. So I use just for anything that would usually be a phony target in the make file. So install deps, and it's gonna be in fact, maybe I won't add the make file after all. So if I go just install deps, okay, I don't think I have support for verbose flag there. I think it just outputs anything if there's a problem. So yeah, that should be all I need. Install. And that doesn't need a cargo bump because it's not really changing any of the project itself. Yeah, I guess if I were to, end of the day, it's down to the programming language in question. So thanks for the question. And I guess it depends on the language specifically and what it's targeting. So, for example, I'm fairly sure those operators are in the likes of C, C++, Rust, and Go, because lots of those languages are, or also the rotation operator as opposed to the shift right and shift left. And so the difference with rotation is that the bit that gets popped off the left or right gets added to the other side. I guess same answer probably is that it depends on what. Well, in the likes of C and Rust and those, I guess they're sufficiently low level that an operator like that could be justified, but at the same time, it would be such a. I guess it comes down by that stage to the distinction, and there's a YouTuber I've seen before that makes a nice argument around this. I can't remember the name, maybe Casey, but the distinction between optimization and he used two terms, and I liked the two terms because I feel similarly, but you're kind of talking about optimization versus kind of performance, and there are nearly two levels of optimization, and I would say in general the optimization that most programmers should ideally be concerned with is the kind of big number optimization. So thinking big O notation and things like that, that there are possibly a couple of hotspots in your program, or they might not even be hotspots sometimes if you don't focus on it enough, but where you can get 80% of your optimization by focusing on improving the performance of like 20% of the code. There's probably a couple of hotspots where, for example, I was dealing with my disk space running out, and the issue really was just that I had to clear my target directory, and I could have optimized, and I was doing to a certain extent. I was looking at all my Docker images, and I was looking at cleaning up my Docker volumes and all these other bits, whereas really the big benefit came from once I actually identified the chunky performance piece. And then there's, I guess, would I say little O notation? Well, I'm not sure, but basically there's the type of performance where you're really zeroing in on individual operations and things like that. So for example, the difference between optimization of a rotation operation versus doing a shift and then trying to simulate the rotation operator using a combination of other operations. And yes, that's less efficient, but at the same time, that's like it depends on your project, but I would say the grand majority of projects aren't going to, unless you're talking about things like graphics engines or game engines, things like that, or really low level things where you're trying to squeeze every bit of performance out of a situation. But even for those, the performance gain or the performance loss you encounter with having a less efficient kind of assembly level operation is not as big. That's going to be the type of optimization that you go to once you've every other type of optimization ruled out, because it's going to be negligible in comparison with lots of other things, even compared to, for example, a function call. Even calling a function call, or if you're in an object-oriented language doing a vtable lookup and things like that to perform a method call, those operations are likely to be so much more costly to the performance that by the time you start looking at optimizing something like a rotation operation, then it's not really going to be the low hanging fruit anymore. It's going to be the last, at least in my opinion, the last number of optimizations you can perform to eke out a little bit of extra performance. And I guess one thing is that, or I guess another point is the fact that with the likes of C, and I would say Rust and Go allow this as well to a certain extent, is that they will, and I guess it depends on the specific environment you're in. So if you're in C Go, or if you're in a certain C dialect and things like that, like maybe you're using GNU C or something, but those will allow, I guess, a variation of foreign function interfacing where it will actually allow you to write a bit of allow you to write a bit of assembly language in the higher level language. Now the assembly language that you're using will be bespoke to the environment as well, but not about an optimization, about language design that describes hardware as close as possible. Okay, yeah, I mean, that's another point as well. And I guess that's another point where it comes back to the, I guess, objective or goals of the language in question. And I guess that's one way of putting it, is that, so in the likes of C, in general, you're kind of wanting to represent the, I guess, CPU model as close as possible, or the machine model in a way, such as, so you want the program itself to reflect as closely as possible what's actually running on the CPU. But at the same time, even at that level, because you're a layer removed from the likes of assembly, which is directly what's going to be happening on the CPU, because you have this level of abstraction, you also have to cater for the fact that the target CPU might not actually support a rotation operation, potentially. So there are C programs that can target, for example, Zilog chips for, I guess, Game Boys. You could have C targeting PowerPC CPUs, RISC architectures, and I guess for the likes of reduced instruction set, maybe the operation isn't one that is present on all RISC architectures. So I get what you're saying in terms of wanting to describe that hardware as close as possible, but at the same time, yeah, I'm just talking about C because that's the one that tends to directly map onto a CPU in that way. With the fact that there is still a layer of abstraction over what's running directly on the CPU, because at the end of the day, even when you do something as simple as, for example, if you do 3 additions in a row and then make that as an assignment, quite often that's not going to map directly to the CPU operations that get performed either, because for example, if we have something like x is equal to, I can't even remember how to write C anymore. Is it int x is equal to 1 plus 2 plus 5, okay, plus 3 plus 4 plus 5 plus 6. Well, first of all, actually, let's just simplify to this. Even in the case that that can relatively easily be mapped to a CPU, or mapped to the assembly instructions, such as, I guess, well, these wouldn't even map directly to plus operations, for example, would they? Because you'd probably have to do something like set, oh, it's been a long time since I've looked at assembly, so basically some register, I'm calling it RAX because I can't remember how these things look, and then you'd set RBX to that, and then you'd do add RAX, RBX, and then you would potentially, even though there are enough registers to perform this operation in like RCX or something, and then add it to what's already there, what you will possibly see in general is that the program will, say, push the first value somewhere else, maybe onto the stack. Well, this is a short example, so it might not push that one. But if there was a longer sequence of instructions, it would probably push the intermediate value to somewhere else while it uses the other registers for the remainder of the operation. And so even though that seems like something that could be simplified to just a sequence of add instructions, because you're abstracting over so many different types, well, first of all, so many different types of execution environment or CPUs or whatever, and also that I guess, how to describe it, the complexity grows so fast once you combine different operations in different ways that I guess when the back end that's compiling the high level language to a low level language, it defines that in such a way that, how to describe it, that it would have to simplify those operations anyway in such a way that they're maybe not the most efficient representation on the CPU, but they're easy to combine in the context of a high level language for when it's targeting a CPU. And so in terms of describing the hardware as close as possible, in that sense, I guess I would kind of argue that in a way that's, if we, again, picking on C because it is one of the languages that most closely, I guess, resembles what's going on in the CPU, has maybe some of the least abstraction, is that even in the case of a language like C that's low level, well, we as humans can see that, and that would be quite easy for us to optimize in that case. But to a machine that's going through it, it doesn't have that, I guess, broad sense of what's going on in this operation. So it's more thinking, and it's also thinking about, well, I've only so many registers. I, as a human, can see, oh, well, there are fewer, I guess, values than I would have registers on my CPU, so I can just use all the CPUs. Whereas a machine that's kind of trying to define these operations in a general way so that they can be combined easily, it's kind of, I guess I would say, if I were developing a compiler to convert that to assembly, I think it would be much easier to define a conversion between two integers and then have that, and then store the value somewhere and then retrieve it and reapply that operation, than to, well, I guess I'm going back to the same thing you're saying in that way, because it is such a simple sequence of operations. But just in terms of, I guess, building up a complicated program from base primitives, then I think it's easier to, and actually I'm after going way off topic, aren't I think, but yeah, coming back to language design that describes the hardware as close as possible, I guess in that case I don't think that's quite what C is trying to do for the likes of C and a lot of high level languages. I think that in general, if you want a language that describes hardware as close as possible, you're going to have to go to something like assembly and the likes, because that's, in a way, what they're designed for. Is they're nearly just designed to convert your instructions directly into opcodes and not really perform any kind of abstraction or simplification over what you've written. Compare maybe a little bit of abstraction over things like addresses and things like that, but compared to something like C, it is, even though it doesn't seem like it, it is quite a good chunk removed from the stuff that's actually running on the CPU. And there are lots of not only optimizations that are going on underneath, but yeah, abstractions as well. And so it might even figure out, and there are different levels of optimization as well. So you have peephole optimization and things like that might take a sequence like this in isolation and see, okay, there are actually 3 operators here, so I'll optimize it and just use all the registers for this. But that's kind of a simplification that is optional. You know, it can default back to the less efficient optimization as well. So coming back to the question as a whole of why not implement that operator so that it looks more like what's happening on the CPU, I think it could even be argued that it could be deceptive, that if you defined a rotation operator like that or something, so you rotated it twice to the left, you may even find that in C it optimizes it to something else, or the CPU doesn't have that operation. Or I guess it's just, at the end of the day, that operation hasn't been seen as maybe ubiquitous enough or necessary enough to justify it being implemented in that way is, I guess, the simplest and probably most likely answer, I would say. But that's just conjecture on my part. I don't exactly know why. I mean, a lot of different languages would have had their own reasons for not doing it, or it could be something that even just didn't come to mind, for example. So, but yeah, thanks for the question. A little bit of a digression, and it made me think about a lot of things that, like, to do with low level programming that I haven't thought about in a long time. Is basic in any CPU and useful in encryption? I mean, it's been a long time since I looked at CPU, for example, CPU level stuff, so I'd have to take your word for it that maybe it is basic in any CPU. But like you say, if it's useful in encryption, there are means of implementing that in lots of high level languages, I think, by for example, inlining certain parts of the code, or not inlining, but using FFI to actually write assembly in the language. So there are ways of kind of mapping directly to the CPU if you need and want to, but I guess it's just not ubiquitous enough a space or a feature to justify making it a language level operation. So, because even if you talk about it being useful in encryption, I mean, that's still only, like, it's a common and useful and important part of computer systems, but it's only one small facet of a broader, shall we say, a broader field in general of computer security, which is itself only a small facet of the computer landscape in general, if we talk about all the different fields of computer science and things like that. So, I mean, end of the day, I can only kind of guess to the reason. For me personally, I mean, I do lots of different projects in lots of different languages, and the presence of, or the lack of, a rotation operator, in fact, lack of or presence of a rotation operator has never been something that's kind of come to my attention. It's not something that I've ever actually kind of had any need for. Maybe the closest would be when I was writing APL, but that was rotating arrays as opposed to rotating bytes. So yeah, if that's anything to go by, that could be a reason in and of itself. If I'm maybe a semi-typical example of a programmer, then lots of programmers might not have a need for that operation themselves. But again, more food for thought than anything concrete. So getting back to here, I added add instruction for installing dependencies. Well, not instruction, it was more a command, I guess. After all this talk about CPUs, I've got instructions on my mind now. So add command for installing dependencies. Add a document. No. So that's that. We'll go back to the Scratch file. Oh yes, and we were going to take a look at the object shorthand. So there was the AST had pair, and I was going to copy over a single, and at the moment I'm not going to have spreading and unspreading, they're going to come later. So there's going to need to be a parser update for this as well. Spread can be removed, and will that work? That won't give me a... Oops. That won't give me a big conflict, will it? We'll see. No, it shouldn't, because it's confined to the context of a object literal. So let's see, we've eval. And let's see. Okay, and that's probably all the code that I had implemented for it, but I must have been very proud of myself that I didn't want to scrap it. Well, it just saves me a little bit of typing. So in terms of integer division, and that operation returns two results and the hardware returns them. So I guess you're talking about the fact that the modulo part of the operation likely gets stored in a register as well. I guess it depends on the... I guess the simple answer is kind of the same as before. Even if that is the case, it's just not a feature that probably has enough applicability to warrant it being included at the language level. Having said that, I potentially would include a feature like that in my language, potentially. I like the idea, so that you could go, for example, I don't know, if you really wanted to, so you could get x and rem is equal to, I don't know, a divided by b. At the same time, first thing is definitely in my language, but also very likely in most languages, bar the likes of C or Rust or those, that's an optimization that would only really be at the language level. So for example, if I implemented that, I guess it's because I'm far enough removed from the back end that I wouldn't be able to optimize it myself anyway. But even if I did, it's likely that would be just a superficial optimization. It would make the operation presentation to the user maybe look more efficient. But I would say for lots of languages, unless they're making sure to directly map that to an efficient operation on the CPU, It's just going to be a language level kind of a more syntactic optimization rather than an actual instruction level optimization. So there's the distance between the language and the CPU, and it's kind of the same argument as before as well, in the sense that, well, actually, one thing to think about is the fact that when those operations are available, then a sophisticated backend, or I guess language. So if a CPU provides those operations and the part of the compiler that's generating CPU instructions is aware of those instructions on the CPU, then quite often the backend can actually optimize and use those operations in a smart way anyway. So using things like peephole optimization in particular, I would say, can actually make use of those operations if they're available, and sometimes potentially optimize the code better than the developer necessarily might. Because if you were to actually code with that style to take advantage of the CPU in the way that the compiler is, you might end up actually writing code that performs well but is very difficult to read for the developer. And actually, that's another good point as well, is that in general, I would say one of the best optimizations you can do for code is to optimize it for readability. And what this does is this will allow the programmer to do what they do best, which is writing code that makes sense, that's understandable to a human, because in general we're the ones who have difficulty reading it, and then leave the complexity of, I guess, optimizing for all these niche cases and optimizing for maximizing the efficiency of the CPU instructions. Leave that kind of work to the compiler and to the backend. So again, I mean, there's I wouldn't say any hard and fast rules there. I don't think there's any reason why you can't do it this way. It's just I guess the more I think about it anyway, the more reasons I would see for not worrying about that level of optimization. So estimates MCU, all C compiler failed to produce a small size code and turn to assembly. Yeah, and to me, I think that's absolutely valid. I mean, the nature of C in general is to be a far-reaching, or a very broad targeting language. I mean, what I feel you're talking about there is specifically using C to target shall we say, an embedded scenario. And that's fine, but that's also only one specific target of C as well. And hey, welcome back. And so you can have, I mean, C also has projects that are very big and there is no way they're going to be embedded. And C also has to cater for those domains as well. So if it added too much optimization for the embedded scenario, which I still think it handles very well, but it could end up going the way of, and I don't mean to rag on any language, I think they all have their benefits, but the likes of C++, where you just have all these tons of features, most of which you probably don't want or shouldn't use, because if you had that level of micro optimization available in C and then you were working on a project that didn't need it, you could have a couple of developers on your team that are like thinking, oh, I have these operations available to me, I'm going to use them in my code, even though in a bigger project that isn't embedded, those optimization, like I was saying before, those optimizations are going to be way too negligible to be worth considering, and are actually going to potentially impair the readability of the project as a whole as a result. And do I have an example of this? Some thoughts were coming to my head as I was saying that, but I guess it reminds me of most projects with a code style, with a coding guideline, will often have a bunch of features that it will say, don't use this feature, use this feature instead. Because what can often happen is, especially when it comes to junior developers, because they're learning so much all the time, is that you can often start focusing on the wrong thing. And I think as developers, quite a lot of us are really focused on efficiency and performance, because clearly we hate waiting for anything, so we want our code to be fast. But it can lead developers sometimes to sacrifice code readability in favor of these kind of micro optimizations, which don't really move the needle enough in the correct direction, but end up sacrificing the readability of the project. And so that's why when you say that the C compilers fail to produce a small size code, that to me is shall we say, an acceptable sacrifice for the fact that I win dollars by turning to assembly to fit the app into the MCU, but any C compiler can't do that. I mean, that sounds that like it's good that C compilers can't do it in that case. And to me, that's also a case where I think that's the right approach. By that stage, the code is so low level that the C compiler can't handle it. And by that stage, yeah, I think you're talking about using the right tools for the job. And by that stage, it seems like either using a dedicated assembly language for that architecture seems like the right approach, or if there's a middle ground, you can use C to kind of scaffold your program in general, and then in your hotspots or any areas of the code where either C is producing code that's too bloated or too inefficient, you can target those sections by inlining assembly language using the likes of, I think, is a GNU assembler and things like that inline in your C program. So yeah, it kind of comes down to the tools for the job, what domain they're targeting. And that's kind of one of the reasons why even in the README for this language and the language that I'll be developing next, I'm going to be very specific in terms of what I'm targeting as the goals, because one of the big things is I see, well, I know it's kind of a gripe I see sometimes, but you see threads where I guess for example, there are developers writing a bash script and they're being told, oh, don't use cat, use a redirect pipe, because the redirect pipe to read in a file will be run by the bash interpreter itself, rather than you having to spawn a new program and it's going to pipe everything in. And I guess there are a couple of different ways of looking at it, and maybe I'm just too much of a noob to understand it, but in general I feel like the cost of spawning a program to read the file and perform that operation versus having bash read it itself in general is probably going to be negligible compared to the processing you're actually going to be doing on the file afterwards. Basically, I feel like they're optimizing in the wrong direction, and so, or optimizing the wrong thing. And so, I mean, at the end of it, it sounds like it's a good thing that the C compiler can't perform the optimizations you're discussing there anyway. So I guess it all works out to a certain extent. So coming back to this mod matching prop, let's see, I think, do I have undefined somewhere else? Object prop shorthand not var, so I'll need to add that as a new error. And I'm not actually sure what or when that error gets raised, so I'll have to take a look. That is now called new location error. And I'll get an error there. Oops. So let's see. Do I have to clone that value? It gets a reference to the mutex. That comes out of scope, and so I'm cloning the mutex and putting it into this variable, or binding it to this spot in the object. Okay, and that seemed to compile. So what I'll do then is start adding tests for this. First I want to, when is the error here raised? In fact, I can remove rs2 now. So if I take a look at the parser and I look at single, okay, so if there's an expression, so let's go to runtime error and our runtime error tests. And I can probably remove this file now, can I? Yeah, that's just some examples. That can be removed. Lexer tests, I think, are in the Lexer module itself. Yeah, so I can remove that. I'll maybe keep those around just as reminders. But yeah, coming back to the runtime errors. And in fact, I can probably remove that and parse errors. Okay, so we've cleaned up a little bit of housekeeping. Any object tests in here at the moment? No. So what I'll do is new test here. Object prop shorthand not var. And let's see. The way I'll trigger that is if, so there isn't a semicolon and the expression here isn't a variable. And so the error location is going to be 1-3, I guess. And it's going to say what? Object and yeah, I'm calling them properties. So let's try that. Oh, that was pretty quick. Wasn't expecting it to compile and run the test that quickly. And I'll just put that into the background for a second and do an NCDU again. So target's gone up to 1 GB so far. So I want to add some actual functionality tests as well. So let's see. Where are my objects and tests for objects? Operations. Probably just in the features file at the moment. pretty sure if this is the right place to put it, but how's ever. Oh no, did I? Yeah, I committed that change and I remember I spotted something. There we go, so that came from the make file. So that should be 4 spaces. Again, something that probably only I would notice, but I noticed it. So I'm going to change it. Anyway, back to business. What's underscore files, I wonder? I have an old Git directory, I guess this is from when the project was called Norpal. I call it assignment or variables. to add a runtime error if the variable doesn't exist as well. That was all passed anyway. So it will go above indexing. And I think this needs to have to be stringified, but we'll double check that anyway. We'll test 2. Cool, so what are the tests that are failing? So variables test seems to work. Oh no, that failed. Oh, it just didn't get syntax, or it just didn't get colored. So for this, I just need to change it to, well, actually, I want to change the error location there. So let's see, undefined. tree and value is not defined. And down here it says B is not defined. Oh, because otherwise it needs to be a string, because it'll actually evaluate the type, or not type, but value. 626. So I think, I haven't added anything to the features here. So it goes above indexing, object shorthand. Okay, so that all passed. And actually I'll add some documentation in a new commit as well to document the fact that keys get evaluated, so that could be a bit surprising to someone coming from JavaScript, that the keys or the names of properties actually get evaluated when you put them in an object literal. I mean, there's for and against with regards to evaluating variables in that way. I mean, in fairness to JavaScript, even though feels a little inconsistent not to evaluate them, in general, the most common case is that you're going to want to provide those property names as names, i.e. as strings, and not as variables that you want to evaluate. So even though I wouldn't really consider it as inconsistent, I think it's probably the right choice. But in this language, I'm prioritizing consistency at the moment. But it might be something that I adapt later on. Did I miss that previously? I think I did actually. Okay, so that's another feature done. Let's see where we are in the Scratch file. We have object shorthand, so we can remove that. And so then next time there'll be, so there's spreading in terms of constructing. So spread is, for example, when we do that, unspread is when it's on the left hand side, so essentially destructuring. And have I, oh yeah, so I've kind of duplicated the terminology down here. So yeah, that leaves us in a good position for next time. With that said, have I anything else I want to do today? I don't think so. So yeah, just all that's left to do is recap what got done. So added the range operation, a little bit of cleanup, and adding the shorthand for object properties. So, and interesting discussion about CPUs and instructions and things like that. So like I say, it's been a long while since I've looked at anything to do with CPUs and assembly language and things like that, so I'm very rusty with all of that, but it was interesting to dive back into that. Yeah, thank you too. And so yeah, that's basically it for today. Thanks very much everyone. As always, thanks for watching, thanks for the discussions, and hope to see you again. Take care.